Okay, event aggregator we've looked at, composition, and now we look at routers. Both of these topics are kind of prerequisites for routers. Routers is a challenging enough topic when you encounter it first, so let's see how we get on. The approach it from a couple of different perspectives. First of all, the notorious back button problem. Back button has always been a problem on the web. When the user presses back, they may be leaving the application space. This is true not just of Aurelia, but any web application may have to find coping strategies for that. We look at fragment identifiers, which is part of the solution, and then we look at the routing mechanisms as implemented in Aurelia itself. Back button, as you know, takes you to the previous page. The user understands how the back button works, and they probably understand that pressing back may take them out of the application, and they may be doing it deliberately. However, if we're in a single page application where we're displaying multiple views, particularly if we've got a menu running and that menu is hosting views entirely on the client side, then the user will expect the back button to take them back in the menu to a previous view, a previous page within the application, not completely out of the application. Now this is a problem with our SPA, because in SPAs, no matter how many levels deep you are, no matter how many views you've selectively revealed or hidden, pressing back once could take you right out of the application completely to the previous site. That's obviously suboptimal in terms of user experience. The hash mark, you may remember this when you were learning HTML originally. If you put hash on the very end of a URL, anything after the hash is processed by the browser. So it's typically used for navigating within a given page. So you press on a link with a hash in it, you're moving up to the top or the bottom of a page. And it permits kind of navigation between pages that are very long. Now, it's been repurposed, this notion, by these single page application frameworks. They all do a bit of work on this. That is, the hash is inserted after the domain for the application itself, and then routes appear down here as if they are routes leading one to ultimately a URL from the source application. Just to clarify that, here is a URL you might see inside an SPA, and notice that in here we've got a hash. This means that everything here is processed by the server, but everything down here is controllable by our own application. It's not sent to the server, and we can populate that with other patterns to indicate to the user perhaps where they are in the application, but also to make sure that we can control and display the current navigation structure. So in Aurelia, as in all these frameworks, we can install a router to manage the hash part of the route. And it will behave as you would expect. It's going to display different view models depending on the pattern. So it mirrors to a certain extent the kind of routing we have been doing with Happy on the server side, except it's all taking place on the client side, and it's something that we have to program and manage. It also means that the default back button in the browser will be reconfigured to track what our router is doing. So pressing back will take us back locally to previous views we may have loaded without any fetch cycle from the domain server itself. So that's quite interesting, and it means that we're able to build up an app that, well, it looks pretty similar to the server-side one we built. Menu along the top, donate, report, candidates, etc., etc. The user can navigate around in this app, and when they press the back button, they'll be going back to previous menu items they may have selected. So how do we do that? Well, takes a little bit of work. First of all, we realized that we might need more than one router, but let's look at that in a second. Here I've got the sign up and the login routes, and you'll see here the patterns we're using: sign up and log in, and you'll notice the hash symbol before these. And here you'll have seen the other routes: home, report, candidates, and stats. In fact, they all more or less match the menus we've established. That's not essential, but we've just taken that approach. To get this to work, we in Aurelia would say we need two separate routers. One router is for our login sign up view. We could have put a welcome in there as well. And the other router is for when a user is logged in. And that has the ability to make donations and look at donation reports and so on. In other words, one prior to authentication and then one for an authenticated user. And we try to keep those separate. Here's what it looks like. In the application view model, we have a new method we haven't been using before called config router. And this new method creates a router for us. And the router will have one entry for every route we wish to support. Our associated view model will include a router view here. That's also new. And that router view is a placeholder into which Aurelia will swap whatever view the router thinks is appropriate. And the view models in this case will either be the login view model or the sign up view model. Each of those will be swapped in turn in to the router view location in the application. This explores in a little bit more detail. We have a navigation bar that we're including at the top. We're then rendering the navigation bar inside our container. And then we are rendering whatever view is considered appropriate or has been selected by the router. The navigation bar itself is a standard semantic UI top menu control, but the actual menu itself is using homogeneous composition. We're iterating through each row of the router itself, pulling out from the router the appropriate fields. And of course that router is just exactly this table we've defined down here. Now it looks quite complex at first contact. You also see we've got active menu support, we've got hbind, and we've got row title and so on going on. Key thing to understand here is that every row in the router is being iterated through via the menu navigation bar at the top. Looking at that in more detail, iterate through the router array, render a single menu item, and then extract out from these the path fragment and the name, which is going to go into the control itself. It's quite challenging now, and you might need to take your time reading over that. These are the basic components of the router. The route itself, this is the thing that will appear after the hash, the string itself. Unique name, the view model that we should be loading, whether we want this to appear in the nav bar or not, and finally a title for the page that's going to be loaded. So for the login router, we have the two login, the login and the sign up view model pairs, and the router itself. Once we wire those in, they will perform automatically. That is, the menu will be automatically triggering either view. Once we're logged in, we need a different router, and this is it here. This one has home, reports, candidates, stats. We also have a logout mechanism. They're all different view models, of course. They're all navigable, and we have associated page title for each one of these. So how does this work? Well, our application now is becoming more interesting and more powerful. We have in our source folder our services folder containing donation service model, some of the fixtures we're using, and the messages we've started to introduce. We have the view models themselves. We're packaging these off now into different folders: candidates, dashboard, donate, login, logout, report, and sign up. Each one of those then is a pair: the view model, which is JavaScript, and the view, which is HTML. Up at the very top level, we've got the application object itself, which starts with a default router. But here's the important point. When we're logged in, we change the router and we load the home application, which has got a different router for the logged in view models. This is our new application object, and it is doing something interesting here. We're subscribing to the login message using the event aggregator, and depending on whether the message says you've logged in, yes or no, success, true or false, we establish the different router. And those routers are home and app. And similarly, once those routers are established, we navigate to a starter page in each one, either donate or login. This is the app view model, and this is the home view model, which has got the logged in router. Okay, that's quite challenging now in terms of what we're doing. We're doing something quite sophisticated though, remember. We're establishing an application that has got multiple views, the back button works, and we're packaging all our multiple views into two sets, if you like. One set for an unauthenticated user and one set for an authenticated user. We are inside in our application view model constructor, listening for login events. And if we get a login event, login success, we switch routers. That's done by setting a new home route, which has got associated router. If the user logs out, we'll be again hitting this event handler, and we'll be changing the routers again to the application router. Okay, that's it then for this week. Let's see how you get on with the labs, and we'll can discuss how that's going as we proceed.